The correct IUPAC name for the following compound is. So IUPAC name, remember, is always the systematic name. And so your first rule in doing that is to find your parent chain. And we do have a chiral center in here. If you look at your options, you see that there's really just two options for parent chains, and then it's just a matter of whether or not you have an R or S. So I think that the first thing to do would be to get the right parent name. So find out which one of these is correct. And then we've narrowed it down to two options. So you've got an ether, an alkane. So we don't have any priority functional groups. So what we want to do is just find the longest carbon chain, the longest continuous carbon chain, and then we're going to number it so that the substituent gets the lowest numbers. So if we go from this side, we'd see 1, 2 would be our first substituent, 3, 4, 5. So our numbers would be 2 and 5. If we were to number from the opposite direction, 1, 2, 3, 4, 5, 6, our numbers would be 3 and 6. So we want to number from this side because 2 and 5 is lower than 3 and 6. So 1, 2, 3, 4, 5, 6, 7. So we have a 7 carbon atom chain. So this is a heptane. And if you're looking at your options, no surprise there, they all say heptane. And then we want to put in our substituents. So we have a methyl at carbon 2, and at carbon 5, we have an ethoxy group. So ethoxy would come first alphabetically, so this would be 5 ethoxy, 2 methyl, I didn't give enough room, but we can kind of squeeze it in there, 2 methyl heptane. So that means that we have eliminated D and B from consideration. And that's just by deciding which way to number the chain. And so the next thing you need to do to decide between A and C is to assign the chirality at the stereo center. So we have that we can see a bond to carbon, carbon and oxygen. The fourth bond that we can't see is hydrogen. And this is a lucky case for us because we have our lowest priority group, the hydrogen, is facing away. And that's where you want your lowest priority group when you are assigning them, when you're assigning your stereo center. So now we're going to compare. We got to give priority to these other atoms that are attached to our chiral carbon. So we see an oxygen, carbon, carbon. So of those, oxygen has the highest atomic number. So that's going to be priority number 1. And so then we need to compare our 2 carbon atoms. So obviously carbon and carbon, same atomic number because they're the same element. So then we need to move farther out the chain. So always go methodically 1 atom at a time until we find a difference. So this carbon atom here is attached to a carbon, carbon, and 2 hydrogens. This next, the carbon on the other side, is attached to carbon, carbon, and 2 hydrogens. That's a common, not a chlorine. Okay, so no difference there. So now we have to go to the next carbon atom. We get to this next carbon atom. We've got 1 bond to carbon and 3 bonds to hydrogen. And so we go on the other side, we go to the next carbon atom and we see 2 bonds to carbon, 2 bonds to hydrogen. And now we do have a difference because if we compare carbon, carbon, that's the same, carbon, hydrogen, there's our difference. So that tells us that this chain here on the left is the second priority and the chain going off to the right is the third priority. So if we draw our arc from 1 to 2 to 3, we see that that is counterclockwise. So that stereo center is S. So we want to say that this is S, 5 ethoxy 2 methyl heptane, which is option A.